Hi guys, this is a quick tutorial on how to complete your experimental probability simulations using Excel. Now, if you have a simpler game where each of your outcomes has an equal probability, don't worry about this one. I'll make a simpler tutorial for you. But this is if you have a game where your three different outcomes have a different probability of happening. So the example I'm going to use for this tutorial is if I have 10 pins and I throw a ring that needs to land on one of those 10 pins. My possible scores are 1, 2, and 3. So if out of those 10 pins, 6 of them are worth 1 point, my probability would be 6 over 10, which would be 0.6. Let's say 3 of those 10 pins are worth 2 points, so my probability for 2 would be 3 out of 10. And out of those 10 pins, 1 of them is worth 3 points, so my probability for 3 would be 1 out of 10. So for this table at the top here, you need to write down when anyone plays your game, what are the possible outcomes that could happen if they throw something or they attempt it the first time. So for me, I had 1, 2, and 3. You may have 0, 1, 2. You may have 5, 10, 20. Whatever it is, you write down the 3 possible scores they can get the first time they throw. Now this is slightly different from our previous example where we looked at our total score at the end. For this here, a much simpler way of doing this is to just look at the 3 possible outcomes the first time they play your game. So we have 0.6, 0.3, and 0.1 for my 3 probabilities. Really, it should add up to exactly 1 if you've done it this way. And so you go equal sum, add it up, you should end up with a total of 1. Because anytime you play this game, there's a 100% chance that you're either going to get a 1 or 2 or a 3. That comes back to your assumptions. This is assuming that every time you play your game, you are successful. So that's a very important assumption to make. Once we've done that, we need to work out our cumulative frequency. So that starts with 0. In our second cell here, we write equal sum, and what we're doing is we're adding together the 2 previous cells. We end up with 0.6, and once again we drag this down to fill in the rest, and you should end up once again with 1 at the very end. Now, looking over here, we have a bunch of scary looking formulas. What we're going to do now is we're going to play our game 20 times. So we're going to use Excel to imagine that 20 different people have played our game and they've thrown 3 times, or they've attempted our game 3 times. Using this formula here, we are now going to experimentally replicate our game. So the first thing we do, in the very top here, trial 1, throw 1, we write down this formula, equals index, bracket. Now the index, we're telling Excel where we're going to find our results. So we highlight our 3 possible outcomes. For me, 1, 2, and 3. Once we have that, the one thing that I didn't do correctly last time, which is why it was all stuffing up, was include these dollar signs. So go back into your formula, and every time you see a letter or a number, write a dollar sign before it. So $B, $4, $B, $6. After you've done that, comma, we are now going to match those scores. So match, bracket, random, because we're going to be randomly selecting these numbers, and we are matching them with their cumulative frequency that lines up with our 1, 2, and 3. So we're highlighting this last 3 numbers here. Once again, it's not D4, D6, it's $D4, $D6. So make sure your dollar signs are going in. And the final thing is we close off our brackets twice, we press enter, and now we have a random throw for our first player. Player 1, their first throw was 2. Now that we have our formula written down, we should be able to drag that down from the bottom 20 times, and now we have our 20 throws. Based on my probability, there's a 60% chance that they're going to get a 1, a 30% chance they're going to get a 2, and a 10% chance they're going to get a 3. So looking at my results, I should be seeing mostly 1s, then a couple 2s, and not many 3s. And having a quick look here, that's pretty much how it works out. Once we have that, we drag it across for our other 3 throws. And now, for our 20 people, we have their 3 throws and we have their outcomes in total. When we randomly generate numbers, remember they're going to kind of change every time we click out of it, so make sure we copy that, right click into our first box here, throw one, trial one, and we paste 1, 2, 3, and that's going to lock those numbers in there. Now that we have that, we need to add up their total scores. So in our total score box, we're going to write equals sum, bracket, and we highlight our first 3 throws. Now we have our total score for player 1 was 5. We drag that down again, and now we're going to have total scores for all of our players. Now, before you kind of copy this and paste it into your Word document, I would just kind of tidy everything up a little bit by putting some borders in, but that's not really terribly important at the moment. This is something you do right at the very end. But for each of our players, we now have a total score. When you've done your tree diagram, which should have been the step before this for your theoretical probability, you would have found the different probabilities for your total scores. So if I've got 1, 2, and 3, and I'm throwing it 3 times, the lowest score I could possibly get would have been 3, and then I could have got 4, 5, 6, 7, 8. The highest score, if I did get 3 threes in a row, would be 9. So in your tree diagram, you would have worked out the probabilities of each of these events happening, and this is now going to hopefully match up with our experimental probability. So just randomly, I'm going to choose a winning score of 5. So if you play my game, the only way you can win is if your score adds up to 5. That's what I've decided for this, completely randomly. What you should decide is, based on your tree diagram, which of these probabilities best matches up to your target percentage. So I'm going to make up some numbers here, completely randomly. But whatever it is, you need to have decided which one of these is going to be my target score in order for someone to win. So I've decided 5. Whatever you've chosen, write that in the top of this table here, because we then need to use our next formula to figure out how many of my players won. How many of them scored a 5? The number of trials, I've chosen 20. 20 is a good amount because 10 would probably be too few. 20 is just enough that you're going to get a good range of values. You could certainly go 30 or 40 or 50, but that's going to be quite a large table. I've chosen 20. In this first one here, the number of wins. Now you could go in and just kind of count it by hand, but if you use this formula, equals count ifs, that's going to count if a 5 turns up. So it's basically counting how many people won. Equals count ifs, we highlight all of our total scores here, and then we write comma 5. I'm looking for a 5 for a win. It will tell me 5 people won, and we can check that. 1, 2, 3, 4, 5. So that's correct. 5 people won. There were 20 trials completed, so we can then work out what is the probability of winning my game based on this first simulation. And if you remember the formula, number of favorable outcomes, which is 5, divide by the total number of outcomes, which is 20. So in our formula here, we go equals 5 divide, which is a slash, and we click on the next cell under it, which was N5. And now we have our probability, which was 25%. In our last step here, we just want to convert that to a percentage. So we write equals, we click on that previous cell, and we multiply, so we use our asterisk, by 100. And now we have our probability of 25%. So based on this simulation, and based on the winning score of 5, there's a 25% chance of someone playing this game and winning. Now, if your probability, your target probability wasn't 25, let's say it was 30 or 35 or 40, then maybe that target score of 5 wasn't the best target. Maybe we should make it 6. And there's a really easy way to change that. Let's hypothetically make it 6. I'm going to go back into my formula here, number of wins, and I'm going to change that 5 to a 6. I'm going to recalculate everything. Now, based on that, only 2 people won. Only 2 people got 6. So 2 out of 20 is 10%. So 6 probably isn't a great target score because only 10% won. The final thing you can do, and you may have decided this in your tree diagram, is instead of just having one number be the target, you may want to make it 2 numbers, or you may want to make it a higher score. So let's say hypothetically, we want it to be 6 or more. So if you score a score of 6 or more, then you win. And there's another way to change that in here. Instead of saying 6, we want to make it greater than or equal to 6. So we go inverted commas or quotation marks, greater than, that symbol there, or equal to 6. What this is going to do is it's going to count up all of the 6s, 7s, 8s, and 9s that appeared, if maybe there were none of them. But we're going to give it a run, and it looks like there are 3 people who scored a 6, a 7, or an 8. So 1, 2, and 3. And so there's a 15% chance of winning if you scored 6 or more. So hopefully that makes sense. This is just one replication, however. So what you need to do is do that a couple of times until you find a percentage that lines up with your theoretical probability. So you would have worked out, theoretically, if my score is 6 or more, then I should be winning 30% of the time. And if your first experiment doesn't show that, what you can do is just do it all over again. So let's delete all of our scores. And let's put our formula back in. So you can just, if you've written it once, you can just copy it and paste it back in. And we just need to make sure that it lines up. So I've kind of overshot it slightly, so I'm going to bring my blue box back there and my red box back there. There's my answer there. And I'm just going to replicate that all over again, run the test again, and we'll see what my results are the second time I do this. Now you may want to do this in a new sheet each time, so you have a copy of it, or you can just do it over the old experiment. You can do either way. But I've got my results here. I'm going to copy them, remember, and paste them so they don't randomly change. Pasting 1, 2, 3. And now I have my scores already added up here. Those formulas are still working to my advantage. If it's 6 or more, this will recalculate it for me straight away. And I can see, apparently there are only 3 people who got 6 or more. 1, 2, 3. So that pretty much tells me straight away that's not going to be a very good score to use because there's a very low probability of that happening. So you may want to fiddle around. Instead of 6 or more, let's make it 5 or more. Maybe that's going to be better for me. Change it to 5 or more. Now I've got 60%. So 5 or more probably won't work either. And that's when you can experiment with, all right, maybe I want it to be either a 5 or a 6. You may want to choose 2 numbers which will add together to give the probability that you want. So let's say a winning probability is 5 or 6. So if you play my game and you get a 5 or a 6, then you win. Now what we need to do is we need to count up again how many times does a 5 or a 6 appear. So what we do, we go up into our count ifs. At the moment I've got count if 5, so you win if it's a 5. Then all we do, if we want a 6 as well, we go plus count if, and we do the same thing. So we count ifs. We do the same thing. We count up our range, and then instead of a 5, we write 6. And now it gives us 11 people. So if we can quickly count how many of them got 5 or 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that formula there works as well. 11 people out of my 20 got a 5 or a 6, so my probability is 55. Now that's a little bit too high, so maybe you'd want to do 6 and 7, or 7 and 8. Whatever it is, you go up to your formula here. After you've done your first count if, you just plus your second count if there. That's hopefully all that you guys will need to know for this. Once again, once this is finished, just take a screenshot of all of that and put that into your solve section. Hopefully your probability of winning here matches up with your target probability and also matches up with your theoretical probability that you calculated in your tree diagram.